Welcome, or hopefully welcome back to another episode of the Reliability Matters podcast. For those of you who are counting, this is episode number 141. Optimization has become an important goal within the electronic assembly industry. While modern electronic assembly techniques utilize a variety of equipment, one specific type of equipment often consumes a disproportionate percentage of the overall equipment budget. That is the pick-and-place machine. The cost of the machine, associated conveyors, and feeders require that the machine is running as often as possible. The airline industry refers to this as wheels up time. Airlines make money when the aircraft is in the air, wheels up. On the other hand, anytime the wheels are down, the aircraft is not making any money for the airline. I listened to an interview a few years ago with the CEO of Southwest Airlines, a U.S. discount carrier. Unlike most other airlines, Southwest does not charge its customers to check bags. The CEO was asked by a reporter why they have not joined the rest of the industry in charging for checked bags. The CEO's answer was genius. If Southwest Airlines began charging for checked bags, it would actually slow down the boarding process as more and more passengers would drag their bags onto the aircraft, most likely resulting in a number of those bags having to be checked at the gate. Southwest Airlines is well known for having the fastest aircraft gate turns in the industry, frequently under 30 minutes. So an aircraft approaches the gate, the passengers are disembarked, it's recatered, the new passengers board the plane, and it's taking off again in usually under 30 minutes. If Southwest Airlines charged for checked baggage, it would require more time at the gate for the next flight to be ready to depart. That would result in fewer flight segments per aircraft day. In other words, allowing customers to check bags for free equates to more wheels up time and subsequently more profit for the airline. The same principle can apply to pick-and-place machines. When pick-and-place machines are running product, they are presumably making money. When they sit idle, they are arguably costing money. What can assemblers do to improve the optimization or wheels up time for their pick-and-place machines? My guest today, Larry Welk, believes that he has the answer, or at least one of the answers. Larry Welk, also known as Professor Splice, is the co-owner of Smart Splice, a manufacturer of tape splicing tools. Larry will review tape splicing best practices and explain how component tape splicing, when performed correctly, can lead to higher pick-and-place machine optimization. So, buckle your seatbelts because this podcast is officially wheels up. I'll be back in just a moment.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Larry Welk, the professor, is in the building. How are you?
I'm great. Thanks, Mike.
Where did the professor come from? Where did you get that idea?
Just kind of came to our head one time because I've been doing this longer than anybody in the industry. So people said, hey, it's just like you're a professor. You know everything about this part of the industry. Nobody else knows more, so why don't we just call you the professor? And started right before COVID, and it did really well over COVID, and now it's taking off again because we're doing more live trade shows and going back at the regular schedule again.
Yeah, the world has opened back up again, thankfully.
Yeah,
I'm not used to seeing you without your white lab coat.
Yeah, that's become a part of my life now. Everybody knows me in it, so.
Yeah, there you go. Hey, if it's working, keep it going. And I do love your education model. I really think that the future of marketing is education because educated people make educated choices. And I think the greatest medium for education, at least today, is video content. And it's really hard to explain what you do with words.
Exactly.
You really need to see it. Now, my audience for this particular episode, I think the words are probably almost enough. But later on in this episode, we're going to show some video content where Larry can actually demonstrate how splicing is done kind of in a more traditional sense and in a modern sense. And for that purpose, if you find that you're getting a little bit of FOMO, a little fear of missing out because you're not seeing something because you're driving, when you get to your destination, when you get home at night or to your office, go visit the Reliability Matters YouTube channel. This is episode number 141, and you'll be able to see some of that fascinating video content. But for now, let's just get started with kind of the basics. Can you explain the role tape splicing plays within our industry? Why are people splicing onto a reel? Why can't they just take the reel out and put another reel in and refeed it? What are the reasons people splice, and what are the advantages of tape splicing when they may not technically need to? Does that make sense?
Yeah. That used to be one of the biggest pushbacks when we started splicing. People said that they could remove a feeder, put a new feeder in faster than they could splice. But that is only part of the solution, because they don't think about the person that was offline loading that feeder, first unloading the feeder, loading the feeder, putting it on a cart, getting it ready. Their time back years ago, that could be 10 or 15 minutes per feeder without thinking twice. So they didn't account for that when they said, yeah, we can pull one out and put one back in faster than you can splice. That was an issue, but it's not anymore, because people are starting to realize how many changes that would entail in an hour and how many times they have to remove a feeder, put a feeder in. So it's a whole lot easier today. And this is how a company looks for a pick and place machine. The first thing they look for, believe it or not, it isn't really the price. They're looking at the rated speed of the machine. And when you go to look at a machine, I've sold machines long enough to know that's not real world. You know that, being out on an assembly line, the real world comes back at you a lot more than what it looks like when you're just rating the speed of a machine. You can pick up and place a board very fast, but where you're missing out is when you put it on the line and you start running out of components on feeders. And people don't realize you have to account for that. So when you buy a machine that's going to do X number of placements per hour, you're never going to reach that after you put that machine into an assembly line, ever, because you're going to run out of parts. And what tape splicing does for a customer, it helps a customer get the rated speed of the machine that they saw in a demo facility, because the machine doesn't stop because of parts being empty, any reels being empty or anything else. The other thing that they don't ever have to do again that makes it faster, they don't have to remove a feeder from the machine ever, unless it breaks. There are a lot of people, I do a lot in automotive, that's a one-piece board that they do over and over and over again, and they never remove it because they just splice while the machine's running. That's the speed of a tape splice, because you can load that feeder with a new reel. The old way was hard because you had a different way to hold the reel. It was held on the back of the machine. So when you put a new reel on, the take-up reel was part of the feeder. And after a while, there got to be so much take-up tape, you had to stop the machine to take that tape off of there. So you don't do that anymore. Now it's down on a rack. You can barcode that reel into your machine. You'd cut all the empty pockets out of the new reel, the old reel, and you splice it together part to part. And you can do that while the machine's running at full speed. So there's
a question for you then. I'm having a hard time conceptualizing this. So here's a reel, right? You have a component reel.
Yep.
The part you load into the feeder is at the outside of the reel,
That's it.
and the end of that reel is all the way in toward the spool, toward the hole in the reel.
Yep.
How does one load or splice on a continuing amount of tape to the end of the reel until they see the end of the reel? You know what I mean?
Yeah. What you learn to do with tape splicing is you program into your machine that you usually want to leave about 2 or 3 feet of components on the reel that's in the machine. Mm-hmm. So basically, your machine, instead of giving you that red light that stops the machine because you're out of parts, you're going to get a blinking yellow light and say you need to replace a new reel onto this feeder. Okay. So what you do is you bring the new reel up, whether it's on a cart or whether it's just by hand, it doesn't matter. But you bring that new reel up and you cut the leader empty pockets off the beginning of that new reel. You barcode it into the machine if you're using ISO certification, that type of stuff, and you unreel the parts that are on the feeder that are there. You take that reel off and you have a 3-foot length of parts that are there. So at the end of a reel, you have empty pockets so that it doesn't bind the parts up and damage the parts on the very inside of the reel. So you cut those off, you splice it together, and you just kind of spin the reel that you are putting on, and that refills that reel, and then you put the new reel on the machine, and then you start them. It just goes. There's no.
The whole time you're doing that, the feeder's still the pick and place machine is still placing components.
Yep. But you have.
So as you're doing it, your 3-foot lead is. You got to do it rather quickly because your 3-foot lead is starting to get a little shorter.
Exactly.
The whole time. Okay.
And that's all right. That's why the old days you used to have maybe 500 parts when you told the feeder that it needed to be done because you used a tool, you used a cart with a tool on it. So it was a lot different than what we're showing people now and teaching them how to do it.
So the amount of time it takes to complete a successful splice is important if you want to be. It's almost like a Formula One pit stop,
exactly.
Where the pit stop crew has to, change 4 tires, refuel the fuel, and do whatever else they do in 8 seconds. It's got to be fast.
Yes.
Wow.
And that's what the new splices that are out there that we're showing now are. We kind of term the old splice with the tools and that type of stuff. That was your grandmother's splice. Nowadays, you want to get into the 21st century. You want to get up to today's way of doing things because feeders have changed over the years and splicing did not for a long time.
Yeah, that makes sense. We're going to show, we'll talk about modern splicing techniques and then we can compare and contrast them to more traditional ones in case someone hasn't spliced in a long time. It is very much like a Formula One. I saw a video on your website as I was doing my research for this conversation that showed a splice being conducted in about 15 seconds, which was, that was a Formula One stop for sure. How does one ensure the quality and reliability of a tape splice? Obviously, they need to be strong. They need to have a good binding strength, and they need to still be rather flexible because they're in a round reel, and the sprockets, the little holes along each side of the tape, have to remain in the same distance apart. You can't just change the pitch on that, or your feeder will jam. So let's just talk about what, from a quality standpoint, from a splice reliability standpoint, what are the key factors?
Well, the hardest thing to convince people of, because they've been using scissors for years. And when I used to get a call and people would say, "Oh, your splice jammed my machine, you're my feeder." And I would talk to them a little bit and say, "Well, let's go through how you did it." And they would say, "Well, I have an operator, they use a pair of scissors." I said, "Well, we can stop right there. That's where your jam is occurring, because you have to cut the splice at a perfect 90-degree angle to the edge of the carrier tape. When you cut that tape, it has to be a perfectly straight cut, because machines now, we're getting down into the micro size of components, resistors, capacitors. They're even now putting some components on 4 millimeter wide tape and special feeders, special cutters, everything. But when you're down to 8 millimeter tape, even what we think of as a standard now, that's still a narrow piece of material going through a feeder. And if you misalign that just a little bit, that's going to jam the feeder, and it's going to happen right where the splice is, because you have a crooked piece of tape going through your sprocket wheel. And you mentioned that earlier about the the sprocket teeth and all that type stuff. That's what the most important part is here, is you need to make sure that that's always straight when it goes through the machine. So that's the first thing we tell people. I don't care if I got to send you a new cutter with the scissors, but you have to have an alignment system on that pair of scissors. The scissors will last. We've never replaced any. They last. So, okay, it's going to be a little bit more expensive than a pair of scissors, but it's important to know that you need that cut. You can't have an operator and a pair of scissors. If they had too much coffee, not enough coffee, whatever the excuse is, they're not going to make a perfect cut 8 hours a day. It's not going to happen. With this scissor, I can go just as fast. They can go just as fast, and you never have a bad cut. It's always straight. That was the first part of trying to teach people how to do splicing. The second part was when you had the old tool, it was felt that it was reliable because it was a crimping tool. You're putting everything in the tool, you're aligning everything, but it took sometimes up to a minute to do that splice. So now you're, the old thing, you never have the best of both worlds. You got to have one thing or another. Here you're doing a tool so that all the operators can do the splice the same, but you're going to give up time to do that. So now, the new style splices that we do, they have an alignment system right on the splice. No more tools. That's why I can do it. And that splice that you saw on my webpage, that was very close to 10 seconds. I can't say 10 seconds because I can't always do it in 10 seconds, but it's down to close to 10 seconds to do a splice on 8mm tape.
So instead of the old days of pulling 500 components, telling the machine to stop 500 components before or 1,000 components before to allow 10 minutes to splice it on, now you can stop it a foot or two before, however many components are in a foot or two, and do it that way. You talked about 4mm tapes and 8mm tapes and various size components come in a variety of sizes, from large quad flat packs, BGAs, to QFNs and things you can't even see. What types of tapes do you typically work with within your world of tape splicing, and how do their properties affect the splicing process?
Well, the old, really old school, they used to have punched metal tape. I don't know if you've ever remembered seeing that, but it was horrendous to work with. It was expensive, and it's pretty much gone the way of the dodo now. But the most widely used tapes are either punched cardboard, but that can only be done for 8mm. And the other one is embossed tape, which is plastic, and it has formed pockets. And that's what you see in 8mm, but you also see it in any size above 8mm because you can't get punched cardboard in above 8mm. So it's embossed and what have you. So the main problem we have today, believe it or not, is the cover tape. And that's an important part of splicing because you have to transfer that cover tape from one tape to the other. As it splices, you have to have a smooth, and that's normally where the error occurs. If you have a problem and you don't have good glue, it's going to wind up ripping the splice where the two pieces of cover tape were spliced together. The old school days, back when I sold taping machines, it was all heat-sealed cover tape. Heat-sealed was a very reliable splice because it used a hot bar system along each edge of the tape. And then they wanted to get faster with that for people building the components, so they went with what's called pressure sensitive. That's great, but there's a lot more chance for error because pressure sensitive, you have to have the pressure perfect. When you're coming out of the end and meeting that with the carrier tape with the parts in it, you have to have a perfect pressure on that tape. And the problem is it doesn't hold up as well. Like if you buy a set of old parts in an old reel, you're going to have an issue because that starts to come loose. And that's been our main problem over the years, has been the cover tape more than the carrier tape. So that was, it's just pressure sensitive it just most of the time doesn't meet spec when it leaves a factory that's building the components. And if your components are coming from offshore, it comes over on a boat, whatever. I mean, it takes a long time to get here. There's more chances for error than there were with heat seal. So when we do anything today, we always recommend heat sealing the cover tape.
Interesting. You talked about cover tape as a challenge. Can you describe any other challenges that tape splicing can bring, and maybe some challenges you've seen where someone said, okay, professor, splice this, waiting for you to fail, right? What are some of the challenging applications that you've seen and that you've had to work through?
One of our largest customers, and they hadn't been splicing much. They actually did all tape extenders at one time, and they were ordering hundreds of boxes a month. But the issue that they had was when they would go to do it, because they were all an R&D facility, so they would have the little rolling carts with the feeders preloaded, and they would be under tension. And when they were under tension, they would have these things preloaded and ready to go a week ahead of time. Tape splicing is not made to do a week ahead of time. As you can see by what we've been talking about, it's put it on, use it, and it goes right through your machine. But when tape extenders, they're getting these ready in these carts for weeks ahead, sometimes a week and a half. So it looks great seeing our tape extenders sitting on these carts all over the factory floor. But when they went to use them, they would come off and they wouldn't pull the cover tape back to start the reel. And I actually went to visit them. I worked with them for a while, and it didn't take me long to figure out what the problem was. So I worked with the actual machine manufacturer to see if we could adjust the peel back pressure. And then I worked with the customer on how they were doing things. I found out basically they cannot do it any other way. They can't do it the day they're going to use it. They need to do it a week ahead. So that wasn't going to be a solution. So the best solution we had, and I worked with the machine manufacturer, and because I worked with companies who sold feeders, I know some of the things you need to be able to do. So I asked them if they could adjust the peel back, and they told me, oh yeah, you just have to do this with the feeder, which the customer didn't even know about, that they could do that. So we adjusted the tension, and then whenever they got one ready ahead, they set it all up, and then they would have the person, before they pushed the cart out, they would roll the feeder, they would roll their hand over the entrance, and that would relieve the tension until they were ready to go. When they were ready to go again, when they went to put the cart in, they pulled them all back and put them back under tension. So that was one time. The other time was somebody who, it wasn't a high-end pick-and-place company, and their feeders were so non-forgiving that they couldn't even withstand the thickness of a splice, which is nothing. It jammed their feeder in the wheel, in the sprocket wheel. I said, that can't be. He said, yeah, watch. So I went there after a trade show one time, and they showed me what the problem was. So I said, he said, the only thing we've been able to do is sand that out. I said, there you go. Because it was a plastic feeder. I said, you have no accuracy here. So we can't make the splice any thinner. It has to work. So that was the only other issue we haven't been able to resolve quickly. And it took them, they had to sand out the feeder a little bit, which is kind of a crazy way to have to do things, but that was life.
I just can't imagine sanding down something on a $150,000 or $250,000 or $500,000 machine. That just sounds like
thing that was nice
quite a weak link.
It wasn't that $500,000 machine. It was a $40,000 machine with plastic feeders. So it wasn't bad, but yeah, that's not a solution on a high-end pick-and-place machine for $500,000.
I would think if they're having a customer audit, that might be caught by the auditor right there. A file. Anytime you see a
standing residue in my components.
Right, exactly. Yeah. Anytime you see a file or sandpaper next to a piece of production equipment, warning, Will Robinson, warning.
Yeah.
Are most splices done offline? I would imagine, you put a full reel in and you do a production run and you've used, say, half a reel. So would someone then take it out of the machine and before they put it back on the shelf, maybe fill it back up? Or, that's probably not a good idea, because then you're always going to have outdated components toward the very end of the reel, I guess. You kind of want a first in, first out. So
Yeah.
It's probably better from a first in, first out, a FIFO standpoint, to refill it when it's near empty as opposed to midstream. Is that
Yes.
just something that lives in my head, or is that?
We're working with because one of the big things in the industry right now, because in the United States, we have more contract manufacturing than OEMs, I think, when it comes to the number of machines, the number of splices. That's why way back when I asked to develop that the cover tape extender we talked about earlier, I got laughed at. And then it became our biggest seller because that's what the United States is about. It's contract manufacturers. They don't have the money to buy, 2,500 extra feeders so that they can keep them all loaded with a specific part for a specific customer. Right. So what they do is they do that. They have to pull it off. And what those cover tape extenders did, they could cut the reel right at the end, right where they didn't have to bother taking it out of the machine, out of the feeder. They cut it right there. Then they could load it with these. They didn't have to save extra tape, cover tape on top of the feeder. It made it faster for them to work. But really, what you just talked about, that we have people in the industry now, a lot of the things that are popular are any major machine manufacturer has a storage tower now where reels can go up. You can put them on. We have a lot of companies now that are competing in the market area where they're doing the reel racks, and you code in what you had. We're working closely with a few of those to try and have them, if there's a certain amount of parts that are not going to do the next run of parts that they have, the next run of boards that they have, that it'll prompt them to say, you need to splice this reel. And they'll splice it before it goes back on the rack. But they'll put the old parts first. They'll have the new reel, and then they'll splice the old parts that are 50 of them left, as you said. They'll splice that onto the end. That way it will be the first off of the reel. So yes, we are working in conjunction with that. And that's just from knowing people in the industry for so long. They come to me and say, hey, can we try and work something out here? And the same with me. I try to contact them to say, this could be an easy solution for you. You can just put a little desk on the end of your rack, a little workstation where you can splice. Real easy.
There are various environmental states that people store components in. In a perfect world, components would be stored in a dry box or at least a temperature humidity controlled environment.
Right.
Contract manufacturers and OEMs, for that matter, come in a variety of sizes with a variety of levels of sophistication. And I've toured a lot of production floors, and particularly in other countries where the humidity is not as well controlled, perhaps, than it would be in other countries. How do environmental factors, humidity, temperature, other factors, impact tape splicing processes in your world? Have you seen an environment where you have to say, okay, you got to fix this environment, or this isn't going to work?
Yeah. We don't have much of an issue. The only issue we have with environment is extreme heat, which I've never found at a customer, but I find when I was using sales reps that, they would throw our splices in the back of a car and leave it there all summer in Texas, and then they go to show a customer how it worked and wonder why it didn't. That's been the only issue we've had in real world. We've never really noticed a problem with that. But the only thing is, as we kind of covered before, the only thing where we have an issue is the splice itself is designed to work now, within an hour or two of being put on the tape, not a week ahead. So we have noticed that, but other than that, and it's the same if you think of splicing, because you have an active glue agent on the splice. It's protected with a piece of, a protective tape, and you pull that off to put the splice on. But when it comes to that, if you do that and don't use the splice right away, or it doesn't get used, that reel you put it on doesn't get used for a week, you've exposed that glue to oxygen, to the natural air around you. So you consider it kind of more like when you're soldering, like when you're putting paste on a board and you leave those boards sit on a rack for a couple hours, you're not going to have a good solder joint when you go to solder it. It's very similar in that regard because you're working with glue. Once the splice is on, and we've had people do that where they've spliced because, let's face it, there's some component suppliers out there that splice. Well, they're getting that ready a week. They send it to a customer. They might not use it for 2 weeks. And we really don't have a big issue with that if they don't put it under tension.
Right.
So,
yeah, that makes sense. What are some of the mistakes people make when attempting to do some tape splicing? You mentioned, you alluded to one, which is not cutting the tape at a proper 90-degree angle. Maybe they
correct.
cut it at a 80-degree angle or 45-degree angle or something.
Right.
What are some of the other mistakes that are kind of persistent within your world?
Well, most of what we found, and it was really using the old system with the tool. Those issues were basically people not putting the little brass clip on the tool correctly and still splicing, so it's not splicing where they had it centered, so it doesn't stick where it's supposed to. And again, if they weren't paying attention, they could lay a piece of carrier tape on the tool, put the other piece, but instead of butting it up against, they had it overlapped by a pocket and not paying attention. And there you have an issue. Normally with splicing, it's normally just training. And in today's world, that's where we're running into a lot of issues because people are in 1 week, 2 weeks later, they're gone. Another group of people come in. That's why the new splice is so popular, because the training is within minutes, not a day, 2 days to train somebody on how to splice. So that's been most of what we've run into. There's, when they, and I'll explain that when we get to that part about comparing some old ways of splicing to the new, but the feeders are so designed so much different, not the internal workings of the feeder, but the most nagging issue that we have when we splice is they've relocated the reel that holds the components. They've moved it down to a tray underneath the feeder, which is great. They can do more stuff, and they don't have that reel hanging behind the feeder getting in your way while you're trying to work on the line. So it's an advantage, but the people that design the machines, design the feeders, didn't take into consideration what happens to the tape when it comes up over a 90-degree edge at the back of the feeder. And that is the biggest problem right now with tape splicing. Because it grabs the tape because you got pockets hanging there going over a 90-degree corner, and you get that thing to splice, and the feeder is yanking it through, so it wants to rip. We're now ripping the splice at the back of the feeder, not at the pick point. So this is where it really has an issue. So that's one of the things we're working with right now to explain to people.
When I was doing my research, I saw, I watched a lot of your videos and read some of your content, and I noticed that there was one particular splice method that had a layman's description, a little metal bridge across the holes, the sprockets.
Yep.
And most of the others were simply tape, not a metal bridge. What would the justification be or the motivation be to use a metal splicing technique versus a more flexible, I assume more flexible tape?
Yeah. The thing, when that metal piece was developed, and that's when they developed what we call the crimping tool to put that in. The easiest way to explain to people, back in the day when the tape was hanging up on the machine, on the feeder, that would go right into the feeder. It wouldn't come up over the edge of the back edge of the feeder. It would go right into the slot, so you didn't have the issues you had now. When you're going nowadays, you're pulling that tape up past that, and you're going at a much higher speed. The feeders are a lot faster because the machines are a lot faster. So what we had the issue with was people would take the metal piece, and they think that's the best way to do it because it's such a supported thing, because it's almost, if you think about a pop rivet going into a fender of a car, If you lose a fender on a car like a Volkswagen Beetle and you wanted to fix that to the car, you could use a pop rivet. But imagine the pop rivet only going halfway through the body. It goes through the fender halfway through the body, but not the whole way through. And then it mushrooms inside there. Well, it can't get anywhere. And that's what that metal brad did. And it was great when it was developed 15, 20 years ago. But people didn't realize, because your tape was more or less hanging down, not coming over a corner, that put the stress on that piece. So when it was hanging down, it was fine. But now it's coming up over a 90-degree corner, and that thing is not through the tape. It's in the carrier tape. And if you look at how thick carrier tape is on where the part is, especially 8mm tape, we're talking tenths or less of a millimeter. I mean, there's no tape there. And yet your splice is going halfway through there and mushrooming. So when it pops up, it's the same as pop riveting a fender. Like I said, if I go up there and take my fist and bang on that fender one time, it just falls on the ground. There's nothing to really hold it. That's the issue today. And this is the problem that we're having with people, because they say, well, we've been using this forever. I said, yeah. And in today's world, they're failing 30 to 50% of the time. So you not only take a minute at least to do that, then you're guaranteeing yourself that 1 out of 3 or 5, 1 out of 3 or 1 out of 2 is going to fail every time. That's that saying, do what you've always done, get the results you've already got. And that's not going to change. It's never going to get better. So that's why people wanted to use the flexibility of a splice that doesn't have that metal on it, because that metal did the support of the carrier tape, and then you still put a piece of plastic material over the cover tape. But now, like the new style tapes, I've got 4 pieces of flexible tape on that 8mm carrier tape compared to that piece of brass and a little piece over the cover. So that's the difference that we're looking at today.
To paraphrase what you said just a few moments ago, the definition of insanity is doing the exact same thing and expecting a different result. Right? So sometimes things have to change.
People tell me that I don't have time to switch. So it's that old MasterCard commercial that you hear. It's like new assembly line, $500,000. Lost production because of a bad splice, $100 a minute. Cost of a new splice, 15 cents a splice, hours and hours with your machine not stopping, priceless. I just ended at end of lesson, Professor Splice, because that's what we're fighting now. People, they just don't want to switch because they don't want to add us as a vendor, or they don't want to do that. And it's like, I can stand here all day and show you how much money you're losing. And
let's talk about that. Let's try and quantify that. If I assume there are some companies, for whatever reasons, that don't do splicing on the fly. Maybe they do it offline or something, because maybe their splicing technology just doesn't allow them a fast enough, F1 pit stop.
Right.
In your estimation, I won't hold you to these numbers, but if let's assume that there's a certain rating of component placement per hour, 100,000 placements per hour.
Yeah.
That's the braggadocious, marketing pitch. In reality, they're getting 50,000 components an hour. In reality, that could be a number of reasons. It could be just a huge variety of components, or certain components just place slower. I don't know what the reasons are, but it also could be because they didn't allow time to change out feeders and things like that. Mm-hmm. Assuming that that's the primary slowdown compared to the optimum number, what percentage, how much closer to 100% placement, advertised placement, can they get if they never ran out of components on the feeder?
I can actually give you a real world scenario.
Great.
I was at one of the largest customers in the United States. 32 lines, divided 16 and 16 with different types of feeders, which means they're not the same machines. They needed 2 different types of splices. In that time, We evaluated, I was at that customer for 9 hours with a stopwatch, showing them how many breakdowns they had. And I'm talking only because of splicing issues, whether they're people that were doing it now and they were using the old tool, they were using old style splices with the metal piece on all the ones that they did. And in that time, they averaged over 9 hours, they averaged 7 to 10 line down situations per hour. And I started showing them the time. In that hour, they were averaging 20 minutes of wheels up time, 20 minutes on a machine that's supposed to do 50 to 60,000 placements an hour. So I sent them samples. We had them do that. In the first week that they tried the new samples, they upped their production rate 60% in 1 week. And all I kept hearing from them for months and months, we don't have time to do this. We don't have enough employees. We're short-staffed. I said, I can train somebody how to do this first time in 1/3 the time they're spending on a splice now. And half of their shutdowns were because the operator couldn't, as you mentioned at the very beginning of the show, this operator couldn't do it fast enough. He couldn't do the F1 stop. He had to do the NASCAR stop when you got to pull dents out of the car and all that stuff. That's what they're dealing with. So half of those breakdowns were because they had to stop the machine and they had to take the feeder out, load new tape into the feeder live at the machine because they're splicing. They don't have another feeder ready with components. So they're just and I'm like, this is like the elite of people in the United States. There's not too many companies in the United States with 30 pick and place lines or more. That's other parts of the world and not the United States. So I'm like, you keep telling me you don't have time to switch because you don't have the number of employees you need. I can show you how you can get more out of the employees that you have, even if you're shorthanded. Because the new splice material takes 10 minutes to train, and somebody's already doing it in 1/3 to a half less than what it is on the tool first time. So that's real hard. You know?
We don't have time to do it right, but we find time to do it over.
Over and over.
So for my audience who are in the car driving or on the treadmill or somewhere with headphones on, you're not going to be able to see this, but Larry will do his best to describe what he's seen. The first, just to set up this video, Larry, this is a video of what you would call kind of a more classic method, say an older method of tape splicing. I was impressed by that, so I'm looking forward to hearing the contrast between the old method and a newer method. But let's show our audience who are watching what we're talking about. Describe what we're seeing here.
Yeah, I'm just showing you, this is the old splice with the metal brad and a piece of splice tape all on one unit. And I'm going to show that's the one piece unit. The old way used to be separate brass pin and a piece of splice tape. And now I'm cutting a piece of cardboard material with the alignment scissors and showing you how this splice goes on. You actually have to open the tool first. You have to align the brass piece on there. Then you have to put 2 pieces of splice tape that you cut, one on one side, and then there's a pin that holds it in place so it doesn't fall out. Then you put the other piece of splice tape in there that you're mating it to, put the pin on there, spin it around, and then you crimp down, and it's a self-crimping thing where you squeeze it down, it clicks, and then at the end it automatically releases. So now you've got your splice on it, and you remove it from there, and then you have to take the time to fold that piece of splice tape around, remove the protective tape, and then you push it down. So that was actually a pretty quick one because that's working on a table, not at the machine while you're under the pressure to get it done. But that still took more than half a minute, probably 40 seconds or more. And then it just shows how the cover tape comes off. And it works. It's not like it's a bad splice. Then we're showing you that was on 8mm tape. Then basically we do the exact same thing on an 8mm embossed tape, which is pretty much the same thing. The downside to that system was that it goes around the outside of the tape to come up around with this piece of splice that goes on the cover tape. So we had to, when we made more of those for larger splices, you had to come around and you could have a very deep pocket, but you had to have the tape come around so that you could use that that large piece of carrier tape to go around the front of the unit to go around the splice tape. So it takes much longer on a larger piece of splice tape. It takes minimum minute and a half to get all that taken care of once you get the metal part on there and crimped on.
Okay, now let's compare that to a more modern method. Explain what we're seeing here, Larry.
This is the same kind of scissors. This one I show the 8mm tape again, and it shows there's different pins on the cutter for different pitches of tape. But there I make a cut. This new one has the splice on there with pins you can see on here. There's actually alignment pins on the splice. You pull the tape halfway back, and then you're going to match it up. So this is what we were doing on the front of that tool. We're doing right on the splice live while it's running, while the machine's running next to you. You just put the two pieces together. It's very easy. It already has an alignment done. And now we've even changed the way we put that splice on. It's even faster now because you actually here you're removing the pins, and now you've got a piece of cover tape on there for the front. And on the back, because this was a Panasonic type setup, then you pull the protective tape on. You got two pieces of tape on the back. One goes over the sprocket holes because it uses an emitter and receiver feeder. But you see, very reliable. And that splice basically took 10 to 15 seconds to put on. So you're getting the same result. Two more pieces of tape on there for support. And this one even goes to the length of showing you that I can go almost as fast with a 32mm tape as I can with an 8mm tape. So you don't lose speed because of the size of the tape. You might lose 5 seconds more, but you also lose 30 to 40 seconds more using the tool. So this is where I cut
that's a different
30
type of cutter. That's more of a guillotine cutter versus scissors there.
Because
that we're seeing.
the large tape, it supports it because you've got pockets on both sides. So you're supporting it very easy. But you can see the actual tape itself, I'm putting on exactly the same way. You have pins that are through there, and all I do is fold the tape over on each side. And on this video, it's not going as fast as I can. I'm just using it to show people how to do it. But you remove the pins. That's a removable piece. You fold the tape, and it's perforated, so it can only fold perfectly the way you need it. Then when you're done, when you're done on this one, you've got a piece over the cover tape. I've got a piece on the top sprockets on each side because it's 32mm, and I've got a piece on the bottom of each side. So I've got 5 pieces of splice tape on a 32mm tape. If you did 32mm tape with the other one, you had to put a metal brass clip on both sides because you've got to have support on both sides where there's sprockets, or when you go around the front of your feeder, your tape will jam the feeder. You've got to have both sides supported. So not only did it go slow because you used the tool, I had to use that tool twice to put that brad on the other side. So we try and show people and this is why that tool is why a lot of people stopped splicing. They had so many bad experiences with it. They said, it's faster just to load a feeder offline and do that. So they kind of went backwards. They didn't like splicing anymore. And when I go into a facility now and I show these people who have had a bad experience with this new splice, they're like, their jaw just drops and they look at me and it's like that aha moment. It's like, it really can be that easy? I said, every splice you do can be that easy now. So that's the difference.
So we're about out of time. So Professor
Correct.
Professor Welk.
Yes.
What parting advice would you give to my audience on evaluating the splicing methods and calculating an ROI? It's hard to imagine an ROI. I can't imagine a splicing tool costs $100,000.
Yeah.
It's really more of a cultural change. It's a mind shift, right? In the perceived cost of labor versus the perceived cost of, or perceived savings and return on investment of that labor. What would your parting words be to technicians and engineers that are working a pick and place machine line and might have to come across tape splicing applications? Let's kind of put a bow on all this.
Yeah, I think the most important thing is we're starting to see more conversations between purchasing and people on the line. That was the big gap before, because people used to look at tape splicing as an added cost on the assembly line. They weren't looking at it as what tape splicing was originally designed to do, was to get your machine up to the production rate that it was bought for. So we try and tell people that if you spend too much time trying to calculate and concentrating on the cost of a box of tape splices, you've missed the whole boat. That has nothing to do with value. And value today, most of the time, the cheapest company is not the best value. You want something to work. You want something to last if it's a machine. So really what you're looking at splicing today is not how much it costs you a box, but how much it makes you, as you say, wheels up. That's tape splicing. It's to make your pick and place machine more productive because you're running it all the time. And I mean, I've been back to people that have used splicing, and when you can go 2, 3, 4 hours without, I'm not saying the line doesn't stop. I'm saying that the pick and place machine doesn't shut down because of a splicing error, because there was a feeder error, because the splice broke or anything else. So that's the best way to look at splicing. It makes you money. When you're looking, like you said, $100,000 for an ROI, here I'm spending 15 cents a splice, and maybe I do that 20 times in an hour. It doesn't matter what that box costs because you just made X number of dollars that your machine was rated at when you bought it. That's splicing in a nutshell.
Well, that sounds like good advice. Larry Welk, AKA the Professor, always fascinating to talk to you. Thanks for sharing your expertise and your decades of experience in the world of splicing. You and I share one thing in common, and that is if we go to a cocktail party and someone says, "What do you do for a living?" You just almost want to lie and come up with anything else because it's a rabbit hole. It's a rabbit hole.
Yeah. 38 years in this industry is a long, so people say, don't tell God what your plans are, because I said I would never be a salesman. But I don't look at it as a salesman. I look at it as a trainer. I like to train people on the best way to get production out of their line.
I think the best salesmen don't consider themselves salesmen. I remember hiring a guy. I was interviewing someone years ago. We bought a copy machine, and we had it delivered. It was brand new, and it didn't work. It wouldn't run. So I'm ready to just boot it out. And the sales manager who was there for the install was all embarrassed. So he made a quick call, and the technician came out. And the technician looked at me and said, "Mr. Conrad, I got this machine ready. That's my job. Something happened. I'm going to fix it, and I will not leave here until this machine is running." And did his magic tricks, and the machine was running fine. And after his boss left, he turned to me and he goes, "You guys hiring?" And he goes, I'd love to be a technician for you." And I said, "How about a salesman?" And he looked at me and he goes, "I don't like salesmen." I'm like, "You are our next salesman." And I hired him on the spot. Well, no, I made him an offer on the spot. And he became eventually our sales manager, quite successfly. And it was because he didn't have that sales mentality. He had a customer solution mentality. Yeah.
Excellent. Yeah. I'm solving a problem for a customer. That's what we do.
Right.
And that's what people are starting to see. It's like, yeah, I'm not all about money. I said, I'd like to see you get more production out of your assembly line. So, yeah.
Wonderful. Well, Larry, welcome. Thanks again for being my guest today. It was a fascinating conversation. And if my audience would like to contact Larry, the information will be in the show notes. If you're listening to this on your podcast, when you get home or back to your office into a safe location, go on your podcast site, look at the show notes, and Larry's information will be there. If you're watching this on YouTube, there is a button down here somewhere that says see more or show more or something to that effect. Click that and you'll see Larry's contact information in the show notes.
Great.
Larry Welk, the professor, been great to talk to you.
All right. Thank you, Mike, for having me on the show.
You're very welcome. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Be sure to subscribe to the Reliability Matters podcast on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments, episode suggestions, or questions to mike@mikeconrad.com. Just remember that's Conrad spelled with a K. Once again, thanks for listening or watching. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.